Hello, Luke. Welcome to Lesson 76. So today, as you may have already noticed, we will be skipping Lesson 75 and moving on to Lesson 76. So don't get mixed up in your seat work today. You're actually skipping Lesson 75 seat work and going right on to Lesson 76. We will be doing Lesson 75 seat work as well as the lesson tomorrow. I just don't quite have that one ready yet. So instead, we'll be doing this one today. Today we're going to be talking about consecutive integers. So let's go ahead and get started. We're working today with basically story problems dealing with consecutive integers. Now, you know what an integer is, hopefully at this point, right? So we know integers are numbers like 1, 2, 3, 4, the whole numbers, and then also the negative numbers, -1, -2, and so forth. We don't have fractions in there, all right? And then we know what consecutive means. Consecutive just means one right after the other. All right, so if I say starting with the number 2, what are the next two consecutive numbers or the next two consecutive integers? It would simply be 3 and then followed by a 4 because that is the order in which the numbers are. Okay, so let's take a look at a couple of story problems here dealing with consecutive integers. And the general strategy here is to write down the information that they give you in these story problems in an algebraic way, and then use the algebraic way to solve for the unknown numbers. Okay, so let's take the first one, and hopefully that will kind of enlighten you and it'll make more sense. So find 3 consecutive integers such that the sum of the first and third is 146. Okay, so the key to all of these problems is really the setup. If you can get the setup down, the rest kind of falls into place. Okay, so the first thing we need to recognize is that we're dealing with 3 consecutive integers. Those 3 words there are super important. That's kind of the foundation for this entire problem. All right, we're dealing with 3 consecutive integers. We don't know what they are. So we are going to give them a variable name. All right, but this is where it gets interesting. I could give them a variable name like, n1 for, the first integer, and then I could give it n2 for the second integer, and n3 for the third integer, right? That might seem to make sense, to have these 3 different variables representing the 3 different integers that we're trying to find. However, there's kind of a trick to this, because this word consecutive actually gives us a little more information, and we're able to write this in terms of 1 variable instead of 3. Because if we have 3 variables, here, here, and here, we have to solve for these 3 variables. But instead, with a little bit of trickery here, or maybe not even trickery, just a little bit of insight, we can see that we can actually write this in terms of 1 unknown, 1 variable, because these integers are consecutive. That consecutive is the key word here. Okay, so if they're consecutive, let's take the first number, the smallest number, and we're going to name that one n. Okay, that is the smallest number, just n for number. All right, now we don't know what the second number is. We named it n2, n sub 2 up here, but we don't want to use another variable. So how could we write the second number in terms of the first number? And the answer is we know that these are consecutive, so the second number is simply going to be the first number plus 1, right? So going back to our example over here, if the first number is a 2, the second number is just simply 2 plus 1, right? Which of course is 3. But that's the second number because these are consecutive, which means every new number is going to go up 1, right? So the second number, instead of just being n, it's going to be n plus 1. All right? Make sure you understand that. Now, let's look on to the third number. What would be the third number? We don't want, again, n sub 3. That's a new variable. We're trying to avoid that. So instead of writing n sub 3, what could we write in terms of n that would accurately define n sub 3, the third number? Well, any ideas? How about the original n again, whatever this number is, this n, but now we're going to add 2 to it. Okay, we added 1 for the second number. We'll add 2 for the third number. And that coincides with how it would work in the real world over here. If I start with 2, my second number would be 2 plus 1. My third number would be 2 plus 2, which is, of course, this 4. Okay? All that we're doing is just replacing this 2 with an n. Okay, and getting the same setup. All right. So the beauty of this little insight is that now we have our three numbers defined, and they're in terms of one variable instead of three. We're only using one variable, which will work out really nice when we start trying to solve the equations for this. All right, so we have n for the first, n plus 1 for the second, n plus 2 for the third, because they are consecutive. If it didn't say they were consecutive, we wouldn't be able to do this. All right? Okay, so now let's keep going with the problem. So find three consecutive integers such that the sum of the first and third is 146. We kind of need to understand what this part of the problem is saying algebraically. And this is where we have to kind of put on our thinking caps here and make sure we're understanding what they're saying. So the sum would be indicating the answer to an addition problem, right? So we've got something that's being added together and we're getting some answer to that. That's what the word sum should tell us. Now what are we adding? Well, we're adding, it's the sum of the first and third. So the first and third number, first number and third number are being added together. All right. And then of course we have this is. Now remember, the is in math means equals. So the sum of the first and third, we add the first and third, and that is, or that equals 146. Okay. So we've almost got the setup now. The first number. What is the first number? How did we define the first number? Well, remember, maybe we'll change colors here. The first number we defined as n. So we're taking the n plus the third number. Well, how did we define the third number? We defined the third number as n plus 2, right? So it's going to be this n plus, and maybe I'll just throw this in parentheses to make it more clear, n plus 2 is equal to 146. Now, the beauty here is that we have an equation. We have an algebraic equation, and it's in one variable because of this little trick here in our setup. All right? It's in one variable, which means we can solve this. It's one equation in one variable. So let's go ahead and solve it. This is just basic review at this point. Now it's just crunching numbers here. So we have n plus 2, being that this set of parentheses isn't being multiplied by anything, we can drop the parentheses and get n plus 2 is equal to 146. All right, now we can combine like terms. N plus n is 2n. And I'm at the same time here, maybe I'll change colors. We're going to subtract a 2 from this side and subtract a 2 from that side, just to move the 2 over. And that's going to equal 146 minus 2, which is going to be 144. I know I'm taking a couple shortcuts here, but I think we're at that point in equation solving that we could probably do this. All right, and then we can divide both sides by 2 to get n by itself, right? And that's going to give us n is equal to 122. Okay, so are we done? Well, we have to think about what this n means. This means that the first number in our series of three consecutive integers is 122. This one right here. We can replace this guy with 122. Okay, what would the second number then be? The second number would have to be 123. And the third number would have to be 124. Once we know the first one, we know the rest of them. All right, so the three consecutive integers in question here are 122, 123, and 124. And if you want to do a quick check on this, just go back to what they were saying about these numbers, and that is the sum of the first and third has to be 146. So if we take the first and the third and we add them up, what do we get? We get 122 plus 124, which is going to be equal to 146, which is exactly what they're saying it should be. So we know we did it right. All right? So hopefully this all makes sense to you. Really, the insight that you need to remember is how to set up the problem. And that all goes back to getting it into one variable, recognizing that because they're consecutive integers, we just simply add a 1 to every new number in the series. All right? Okay, let's try another one of these. Maybe go ahead and just try this one on your own first, and then we'll do it together. All right, so they tell us find three consecutive integers. There's those very critical words there, three consecutive integers, such that twice the sum of the first two is 2 less than 3 times the third. So we have a little bit more of a complicated equation here at the end, but the first part is essentially the same thing. We're trying to find three consecutive integers. So once again, we will label them, or we will define them as n is the first number, and then because they're consecutive integers, we'll have n plus 1 is the second number, and n plus 2 is the third number. Okay? All right, now we have to look at the equation, so the last part of the problem here, such that twice the sum. All right, so twice the sum. The sum would indicate an addition problem. So we're adding something together, but then we're taking twice that, and twice would indicate multiplication by 2. So we're taking an addition problem, and then we're multiplying it by 2. Okay? So if you want, go ahead and write that out. We've got an addition problem, something plus something, and that addition problem is being multiplied by 2. Okay, twice this sum. All right, now what is the sum? Well, it says twice the sum of the first two. So twice the sum of the first two, and this first two would mean the first two numbers, right? So the sum of the first two numbers. Well, what's the first number? The first number is this n. So it's going to be the sum of the first number with the second number, which is n plus 1. All right? So that's part of our equation taken care of. Now, what do they say this is equal to? Well, look for the is. Look for the is. Here's the is. I'm covering up my number there. Here's the is. That's our equal sign right there. So at this point, we can say that this twice the sum of the first number and the second number is equals 2 less than 3 times the third. Okay? 2 less than 3 times the third. So we have to be careful here. It's not 2 minus 3 times the third, even though you might be tempted to write it in your head or on paper like this. And this third, by the way, would be what? It's the third number. So we could think of that third as this one, the third number, n plus 2. Watch out. This, even though we're kind of translating it very literally here, in line, 2 is less than, meaning minus, then 3 times the third. This is our third number. Okay, so we kind of just wrote that exactly the way we see it in the problem. However, this less than, I think we've talked about this before, this less than can be tricky, okay? It's not really meaning what it appears to mean. It does not mean 2 minus 3 times the third. Okay, it's actually the opposite of that. 2 less than. It means we're taking 2 away from something. This does not show 2 being taken away from something. This shows 2 is being added to a negative number. If anything, something is being taken away from the 2. Do you see that? This minus here, something is being taken away from this 2. All right, and that's not what they're saying. They're saying 2 less than, meaning 2 is being taken away from something else. All right, so it's kind of the opposite of this. The correct form here would be 2 less than what? 2 less than 3 times the third. So we have to take 3 times the third number, which we just said was n plus 2. So it's 3 times the third number, and then we're taking 2 away from that. So it's minus 2. All right? Make sure you can see the difference between this form and this form. Okay? This one, we're actually taking a 2 and then taking something away from the 2. That's not what they're saying here. All right? Here we're taking something, this 3 times the third number, and then we're taking 2 away from that. We're subtracting 2. We're taking 2 away. That's what we want. This is the correct form. This is the incorrect form. So do not fall for that mistake. It's very easy to do. Watch out for the less than. Make sure you understand the problem. All right, so, but this is now the right-hand side of our equation. So we have 3 times n plus 2 minus 2. Okay, so that is our equation. It's a little bigger than the last one. But again, note that it's all in one variable, which is great because we know how to solve equations with one variable. So let's go ahead and do that. Let's solve this one out. So we have some distributive property going on here, but we could work in the parentheses first. So we could say this is 2 times what's n plus n. That's 2n plus 1. Okay, that's everything we can do in that set of parentheses. Here we have some more multiplication, but there's nothing that can be done in those parentheses. So we're going to distribute this 3 through, and we're going to get 3n plus 6. And then, of course, we have this minus 2 still on the end. Okay, then maybe we go on to the next step here and just distribute this 2 through. So we have 4n plus 2 is equal to 3n plus 6 minus 2, that's going to be plus 4. Okay, now we get our n's all on one side. We'll subtract the 3n here, and maybe we'll combine a couple steps here. We'll also move this 2 over to the other side. So we'll subtract the 2 from this side. Okay, and that means we have to subtract it over here, and we have to subtract the 3n over here. Okay, so the 2's will cross out. We have 4n minus 3n. That is going to be an n, which is great. The n's cross out here, and then we have plus 4 minus 2, which is a 2. So n is equal to 2. And if this is 3 consecutive integers, then our integers are going to be 2, 3, and 4. So that would be our solution. And if you want to double check it, you can just kind of think about what they're saying here, such that twice the sum of the first 2, so we take the first 2 numbers, 2 and 3, their sum is 5. We take twice of that, that's 10. All right, so that 10 is equal to 2 less than 3 times the third. What's 3 times the third? 3 times the 4 is 12, and then 2 less than that is 12 minus 2, which is also 10. So it's true, 10 does equal 10. So there you go. That is the solution. All right, let's try another one. Okay, let's try this one. Remember what you learned in the last one. It says find 4 consecutive integers. We're doing 4 this time, such that 6 times the sum of the first and fourth is 26 less than 10 times the third. Watch out. I see a less than there, so don't fall into that trap. Go ahead and take a minute here and try to do this one on your own. All right, so let's do it together here. So find 4 consecutive integers. Well, once again, what are those integers going to be? Well, the first one, we're just going to call it an n because n makes sense for numbers. All right, and then what's our second one? Well, it's going to be n plus 1. Our third one is going to be n plus 2. And our fourth number now is going to have to be n plus 3. right? So there are four numbers, four consecutive integers. Now, what are we saying about these? Well, we're saying that 6 times the sum. So again, we have a 6. It's being multiplied by a sum of something. What is the sum? It's the sum of the first and fourth. Here's our first number. And our fourth number is over here. So it's n plus 3. So there's our sum, and it's being multiplied by 6. And then after that, we hit our equal sign. Is. So we have our equals. 26 less than 10 times the third. So again, we're going to do the second part first because this less than comes at the end, even though it seems to come at the beginning. So 10 times the third. So we're going to take 10 times the third number. What's the third number? Well, that's n plus 2. So there's our 10 times the third. But now we're taking 26 less than that. 26 less than this. So we need to subtract 26 from that. Okay? All right, then we can go ahead and just solve the equation. Do what you know how to do here. So we'll do it right now. Looking at our parentheses, we can combine and get 2n plus 3. Over here, we can't combine. We're going to distribute through and get 10n plus 20 minus 26. Now we'll distribute through on this set, and we'll end up with 12n plus 12n plus 18 equals the 10n plus the 20 minus 26, so that's going to give us a minus 6. Now we're going to move our n's over, get all of them together. So we'll subtract this side from both sides. And let's see, let's move our integers over. We're going to move this negative 18, or this positive 18 over to the other side. And to do that, we change it to a negative 18. So we end up with 12n minus 10n, which is going to be 2n. These cross out. We have the n's cross out here, and we have minus 24. All right, so then we divide both sides by 2. So now n becomes 24 divided by 2, or negative 24 divided by 2 is going to be a negative 12. Now watch out with this one. This is kind of interesting. N is equal to a negative 12. We haven't had a negative answer yet. So what's our consecutive integers here? You might be tempted to say that they're negative 12, and they're negative 13, and negative 14, and negative 15. But this would be incorrect, okay? This is not right, wrong, okay? Why is it wrong? Because these are not consecutive integers. Consecutive integers means they move from the left to the right the same way that they would on the number line. All right, so if I have a number line, and right over here is where negative 12 lives, consecutive would mean the next number in the series would have to be at this location, 1 unit to the right. And then the next number in the series would have to be here. And then the next number here, and so on and so forth. Now, if you think of it that way, is this next number a negative 13 like we have here? And the answer is no, all right? We're 12 in the whole here. As we work our way to the right, the numbers become bigger, which means we start working our way out of the hole, which means that this is not a negative 13. This is going to be a negative 11, right? Because we're working our way out of the hole. And this is going to be a negative 10, and this will be a negative 9, and eventually we'll get to this 0, all right? So be careful. The other way to think about this is, here's what we got was a negative 12. Remember, though, if this number is a negative 12, the second number is going to be that negative 12 plus 1. So the second number should be negative 11, because that's what negative 12 plus 1 is. And the negative 12 plus 2 is going to give us a negative 10. And negative 12 plus 3 is going to give us a negative 9. So you can see that the integers in question here are actually negative 12, negative 11, negative 10, and negative 9. Those would be the integers. Okay? Hopefully that makes sense to you. Maybe you didn't make this mistake when you did it on your own. But if you did, don't worry about it. Now you understand why that's wrong. Okay? They have to be consecutive, which means they have to be getting bigger. We have to be adding an integer to every new number. Okay? All right, very good. And really, that's about as complicated as this is going to get. So go ahead and try these out in your seat work today. Good luck. And I will see you tomorrow.